Okay, so this is going to be part 2, and again, as I said before, this is going to take a little bit of time. These problems are long. I know they're tedious, but they're really not that difficult. So the idea here is just follow along and see what we're doing. But the thing that we have to talk about here is this complex conjugate theorem. So it says if f is a polynomial function with the real coefficients and a plus bi is an imaginary zero of f, then a minus bi is also a zero of f. So I realize that sometimes that letters don't make sense to you guys, and that's okay. Let me just give you an example. If we found that 3 plus 5i was a zero, if that's one of our zeros, then what this theorem is telling us is that 3 minus 5i will also be a zero. And then down here we have irrational conjugates. Well, an irrational number would be something like this. If I gave you 3 plus the square root of 3. That is irrational because of the way that it's written. This theorem follows also that if this is a 0, then 3 minus the square root of 3 will also be a 0. Now, the reason why this happens is if you think about the quadratic formula, when we have that negative b plus or minus the square root, that's where all of this comes in, because the only reason why we would use the quadratic formula is in instances like this anyway, so that's why both of them will end up being your 0. So with that, we have a problem here that says write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and zeros, and they're giving us the zeros. So here's what's going to happen here. Don't worry so much about the least degree, because as long as you do this properly, that's going to work itself out. And the same thing with rational coefficients and a leading coefficient of 1. So here's what we have. Think about x equals 2 as one of our zeros. That means that we have a factor of x minus 2. Also, we have 2i. Just like we talked about above here, if we have 2i as a 0, then that means we also have negative 2i. So what we would write is we will write x minus 2i. That would be for this 0. And then we have x plus 2i for this 0. Then we have 4 minus the square root of 6, which again from above means that we also have 4 plus the square root of 6. So we're going to have two more factors here. One that's going to be x minus, and then we'll have 4 minus root 6. And then the other one will be x minus 4 plus root 6. Okay, so the one thing that you want to pay attention to here is the reason why that's x minus on both of those is because it's always x minus. The only reason why it becomes x plus is when we have a negative. We don't have any negative here, so we're just putting it in parentheses, x minus 4 minus root 6 and x minus 4 plus root 6. So what we're going to do now is we're actually going to multiply out this entire thing, and that takes a little bit of time, so just bear with me a little bit. There's going to be a couple of tricks to this though, and the difference of squares is going to be really important here. We're going to leave this x minus 2 here. But if you notice this right here, x minus 2i and x plus 2i, that's a difference of squares. What that means is our middle term will always cancel out. So all we have to do is say x times x is x squared, and negative 2i times positive 2i will be a negative 4i squared. So that's what we get when we multiply these two together, because the middle term cancels out. If you recall from before, I squared is going to be the square root of 1 times the square root of 1, which is just negative 1. So this will be 4 times negative 1. So when we write this out, it will be x squared minus 4 times negative 1, because I squared is negative 1, which actually is going to give us x squared plus 4. So that's already multiplying these two out, and then obviously we still have the x minus 2 here. Now, dealing with these, and I'm going to put this in a different color so that way you see it. Here is the trick here. We can also make this a difference of squares, but we've got to move our parentheses. Notice we have x minus 4 minus square root of 6. We have x minus 4 plus square root of 6. If we were to just distribute this negative through, it looks like this. X minus 4, and then this would be plus square root of 6, because all I did was distribute this negative through. And then here it would be x minus 4 minus the square root of 6. So here's what we're going to do. And I'm going to, again, change color so that way you can see this. I'm going to change where these parentheses are. Because we can do that. It's not a big deal. You can put parentheses wherever you want. And notice, we now have a difference of squares. We have a plus and we have a minus, which means we're going to take our first term, which is in the blue here, and we're going to square that. So x minus 4 will be squared. Just this is the difference of squares. And then we're going to multiply a positive square root of 6 and a negative square root of 6. So we have square root of 6 times negative square root of 6. And if you recall with radicals, if you multiply two things that are the exact same thing together, the square root goes away. So a positive times a negative will be a negative. So we're going to end up with minus. We're going to end up with minus 6 as our other factor here. So our last factor here will be x minus 4 squared minus 6. So now we've started the process of multiplying this out. So we're going to end up multiplying all of these together. I'm going to start with this one right here. So x minus 4 squared. Again, I'm not going to FOIL this out completely, but you need to be aware that this would be x minus 4 times x minus 4, which will simply be x squared minus 8 minus 8x plus 16, and then we still have this minus 6 at the end. So this 16 minus 6 will actually become 10. So what we're left with is, as I continue down, x minus 2 times x squared plus 4 times x squared minus 8x plus 10. And now what I'm going to do is I'll multiply these first two together first and then multiply by the end. And this is something that all of you have done. You know how to do this. So I'm going to go through this fairly quickly. So multiplying these two together, we get x to the third minus 2x squared plus 4x minus 8. And then we're going to take this and multiply it by our x squared minus 8x plus 10. And the only thing you got to be careful of here is make sure you're doing your exponents correctly. Okay? So again, I'm going to go ahead and pause this video. We've done enough multiplying together, and I'm just going to write out what the long problem would be, and then I will simplify it. So just follow along. You can do this on your own if you want to, but I'm going to pause it. I'm going to write it out, and then I'm going to play it again to save some time. Okay, so we're back, and what I've done is I have multiplied this entire thing out. That's a lot of terms. X to the third times x squared, x to the third times negative 8x, x to the third times 10, negative 2x squared times x squared, negative 2x squared times negative 8x, negative 2x squared times 10, all the way through. And we get all of these terms. And what I've done is I've color-coded all of our like terms that I've combined. So negative 8x to the fourth and negative 2x to the fourth is negative 10x to the fourth. And then we have 10x to the third, 16x to the third, 4x to the third, that's 30x to the third. And then our greens were our squared terms, that ended up being negative 60x squared. And then our yellow terms were our x terms. And then our minus 80 was at the end. So this is what you should have been left with. And I know that takes a little bit of time. That's why I probably won't give you a ton of problems with this, but it's just to expose you to how this would work. Okay, so that's the end of part 2. So remember, part 1 and part 2 is what you're going to do all together, and then part 3 will be a separate day.